Okay, so that was a short lesson. What we're going to do now, we're going to look at integrating by parts. We are in page, the exercise is on page 90, and it's exercise 7.1. I would say that's probably the most important skill to learn when it comes to like more higher level integration. That is the thing that will follow you all the way for a long, long, long time. Okay. I want to start actually not with integration. I want to start with differentiation. You'll see why in a second. Let's say I have, let's call them different equations. Let's say ux times vx. Okay, two functions of x. Now I want to do the derivative of them with respect to x. Each one of them is a function of x. So that's, if you remember, is the product rule. And what we know is that it's basically going to be u prime x, the derivative of u with respect to x, times v of x, plus ux times v prime x, the derivative of v of x. Okay? Now what I want to do, let's use the green button. Just want to make sure you can see it all, yeah? What I'm going to do, I'm going to integrate both sides. Okay, so I'm going to integrate this side and then integrate that side. And I need to write down the variable of integration, dx. You can do that. Okay, to both sides of the equation. Now let's start actually with the right side. I'm integrating a sum of function. So as I said many, many times, the integral of the sum is the sum of the integral. So I can write it like this. And if you don't mind, I'm just going to drop the x. Well, I'll keep it. So indecisive, okay? Dx plus the integral of ux v prime x. This is so important. This thing. What do I get on the left side? It's going a little bit beyond our scope of calculus in AP, but I did mention it. Look, I've got a function that first of all do a derivative to it. That's d to dx, and then I integrate it. Okay? So let's call that function, I don't know what. Let's call that function u. So we'll say h. No, let's call it f. Okay? So f of x is some kind of u times v. Okay? So what I'm doing here, I'm basically doing df to dx. Well, let's start like this. I start with a function. Now I do a derivative of that function, df to dx. And then I integrate it. Well, if I integrate it, where do I go? I go back to the function. Okay? Okay? I've mentioned that as we call it the fundamental law or theorem of calculus. The integral of the derivative of a function is the function. The integral of a derivative of a function is basically the function. I'm doing a full circle. So what I can write on the left-hand side is I'm getting the function. Which one? This function. ux times vx. Now, why is that good for me? That is good for me because I can move this to the other side. So I'll write this on one side, move it to the other side. So I'm going to have u of x times v prime x dx equal to ux times vx minus the integral of u prime x dx. Okay? Now, I developed this proof for you. You don't need to be able to prove it, but this is a formula. This is integration by parts. We're going to see an example now where you have function times function. And let's say we don't know how to integrate it. What I can do is replace this integral with these two functions. Well, this is the same as that. This will be the integral of this minus the integral of the original of this function times the integral of that, or the derivative of that function times the integral of that. Okay, I know it doesn't really make sense right now, but if you manage to understand, this is quite cool. It's a bit of a bonus. You don't need to prove it, but it's quite a bit of a bonus. So I'm going to rewrite this formula for you, and then we'll do some examples. Okay, so let's look at an example. I want to integrate x cosine 2x. Again, if you look at all the methods we worked with, we did have some cosine, but I don't think we ever worked, we had cosine x here and x the same. None of these trig methods that we would try would work here. And substitution also won't work here. Some alarm bells must go, and it's not going to be straight away. It will take time, but integral by parts is the best thing. Okay? So I won't explain how do I know to use this system. We'll do it one first, and then I'll explain why these alarm bells must go on. So we've got two functions. Now so what we write, this is how I was trying to do it, and I think it's quite useful. I'm gonna write u and v prime. Okay? Write the v prime a bit close. Okay? So you see we have this integral. The integral of u times v prime is equal to u times v minus u prime times v. So if I need to decide which one is the u and which one is the v prime. So I just know, and I'll explain later why, I know that I'm going to choose u equal x. And therefore the second, the v prime is going to be cosine 2x. Okay? I know at this point it's kind of random. Why would I choose that? I will do it and then explain why I chose it this way. So what does integration by parts tell us? It tells us that if I have a function times the derivative of a function and I need to integrate it, what you've got to do is just time the two function, that means this function times the integral of this, minus the derivative of that times the integral of that. So I'm replacing it. So what if I start with u and v prime? I need to decide who's u and v prime. Then I just need to say, okay, if u is x, u prime is 1, right? The derivative of x is 1. Where if v prime is cosine 2x, I need to figure out what is v. What is v? V basically, I write down here, v is the integral of v prime. Okay, again, fundamental laws of calculus, right? The integral of the derivative of v is simply v. Okay, so I'm doing differentiation this way, okay? That is d to dx, and here I'm integrating with respect to x. So what's the integral of cosine 2x? Well, it's going to be sine 2x, alright? Because sine 2x will become cosine 2x, but the 2 will jump out, so I need to ambush it divided by 2. Okay? So I write that just like this. This is how I was trained to do it. Okay? Don't need to write these things. This is just for the first time. So I have to kind of guess who's the u and who's the v prime. That will be the u. Okay? That will be the v prime. And then I find the u prime and the v, and now I'm just using this law. Okay? So I know that the integral of u v prime will be equal to 2u times v. Okay, what is u times v? That's u and that's v. It's always that's diagonal if you draw it like that. So it's going to be equal, I'll write the whole thing again if you don't mind. X cosine 2x dx. So this integral, can you see this? Yeah. X cosine 2x dx is going to be equal to uv, u times v, will be x times sine 2x over 2, minus the integral of what? Well, the integral of u prime times v. Here's u prime, that's 1. V is times sine 2x over 2 dx. Okay? Now, I think at this point, it'd probably be useful to explain how did I choose u to be x. Okay? I mean, it's not just because this comes first. I could have mixed them as well. Integrating x to x is impossible. A smart choice will be to choose a u that if you differentiate it, you'll get something easier to integrate, right? So the x, I knew that the x, if I do the u prime, that would be 1. In other words, nothing. I got rid of it, basically. Or if I do the integrate of cosine 2x, I'm just going to get sine 2x, which is kind of like not equal, but it's the same level of difficulty. Okay? So, and here, this one, x, you might say, oh, but x sine 2x, how do I integrate it? I don't need to integrate it. That's the beauty. You see, the uv is outside. We don't need to integrate it. So that's done. This is completely done. Okay? All I got to do is now integrate sine 2x over 2, which is easy. I'll just write this one first, because obviously can't neglect him. What is the integral of sine? Well, the integral of sine is going to be cosine. Okay? But it's not just cosine, it's cosine 2x. Now then I'm thinking about minus. If I differentiate cosine 2x, I'm going to get sine 2x or minus sine 2x. So I've got that minus, fine. So that will be plus. But 2 will jump out. And I don't want that 2. In fact, I want divided by 2. So I need to divide it by 4. Divided by 4. And, okay, the 2 jumps out. 2 divided by 4 will be 1 over 2. And obviously, I still need to add a c, because the integral of this, I will have a constant. Okay? I'll just pause and we'll do another example. Quite a few, I think. Okay, next one. Is it working? Yeah. X over square root 2x plus 1 dx. Okay, let's write it in a more reasonable way. Okay, so x times 2x plus 1 square root minus half dx. Again, here, they didn't tell me substitution, so I wouldn't know what to substitute. One of them is going to be u, and the other one is going to be the v prime. Okay, we need to decide who's the u and who's the v prime. Can you guess who's going to be the u and who's the v prime? Okay, you want to choose a u that if you go from u to u prime, you're going to get rid of it. It will be more simple. And just like in the first case, the right choice of u will be x, because then u prime is simply 1. And then I know that the integral that I'm going to have here will be much easier. So that means v prime, here, v prime is 2x plus 1 over minus half. Okay, so that's a little bit more tricky to find v. Okay, let me write them a little bit closer. Okay, so if this is the integral, or the derivative, the function should have been 2x plus 1 half, right? Because half minus 1 will be minus half. But then I need to time it. Should have given myself more space. I need to time it by 2 because the half will jump out. Okay, half will jump out and you'll kill that 2. But at the same time, I need to divide it by 2 because this 2 will jump out. So in other words, 2 divided by 2, actually I didn't really need any constant here. So it's just that. Let me just check that I got it right. I'm not making a stupid mistake. I think that's all right. Okay. Now, we just use the equation. So once I establish which one is u and which one is v, I'm going to write again the integral of x square root 2x plus 1 dx, okay, is going to be u times v. Let's write the v a little bit closer. Okay, so it will be u times, not the integral, just u times flat out x times, I'll write it already as square root 2x plus 1. Okay, that's u times v minus the integral of u prime v. Okay, but again, u prime is 1, so I don't even need to write it. So it's just simply the integral of 2x plus 1 half dx. Okay, now let's see if we can do that. The first one, okay, it looks complicated, but it's not under the integral sign, so there's no problem there. That's already made. Minus, what's the derivative or the integral of this? Well, I'm going to have 2x plus 1 power 3 over 2, right? So the 3 over 2 minus 1 will be half. Now I need to ambush it with 2 over 3. So the 3 over 2 will jump out, kill each other here, and I've got minus, but remember 2 is going to jump out as well when I do the derivative of that one. So 2 also will jump out. And I don't want that to jump out because I want it to be minus 1. So I need to divide it by 2. Or in other words, it's just going to be minus a third, isn't it? Let's check that. Always good to check. So this is what I think is going to be the integral of that. Then in my mind, I'm just doing the differentiation of that. So the 2x plus 1 power 3 half will be half. The 3 over 2 will jump out. The 3 will cancel. I have 1 divided by 2. The 2 will jump out. 2 divided by 2, we've got minus 1, which is perfect. And that's the answer. Okay, that's the answer. And obviously plus c. Just check again that we're getting the right answer. It looks pretty much good. Yeah. Cool. All right, let's move on to the next example. Okay, a few more examples. So again, we're trying to integrate that. We need to decide who's the u and who's the v prime. Again, I mean, whenever you have x, it's probably most chances that will be the u. Okay, why? Because it's very easy to then see that u prime is 1. You want to make u prime as easy as possible without paying too much of a price in v prime. Okay, so that means that v prime is e3x. Now, integral of exponents is dead easy, and it's not making it more complicated. Okay, so the integral of that is simply going to be e3 power x, but we need to divide by 3. Checking again, if I'm going upward, okay, if I differentiate that, it will be 3 times divided by 3 e3x, so that works out. Okay. Now, and just work it the same like I do. It's really good to see what's your u and u prime and all that sort of stuff. Then, if you don't mind, I'm just going to straight away go there. So I'm going to write that as this integral is equal to uv. What is uv? Is x times e3x divided by 3 minus the integral of u prime v. Okay? e3x over 3. I don't need to write the u prime because it's just 1. Okay? The first one is already finished. What is the integral of this? So the integral of this is going to be e to the power 3x. Now, I know that if I differentiate it, 3 will come out. But I don't want 3. In fact, I want to divide by 3. So I'm going to divide by 9, right? And then I check it in my mind. I see the derivative of that will be e3x times 3 over 9, which is y minus a third, which works out, plus the c, checking, perfect, all good. Let's move on to another one, which is quite an interesting one. Okay, this example is quite interesting. It's quite interesting, actually. So I've got x ln x dx. Now, you might be tempted, as we all did until now, to say, okay, I want to choose u equal x, because then I know that u prime is simply going to be 1. And Mr. Lesham said u prime should be as simple as possible. But then that means v prime is ln x. And then we're stuck. Okay? If you look at this formula sheet, okay, that's the formula sheet that you have. Okay? You don't have a derivative that is ln x. In other words, what is the integral of ln x? Okay? It's the integral of ln x. And I imagine there is a way of calculating it, but I think I don't know what the answer is, and it's really, really difficult. So that actually will not work. So when that happens, what do? Well, you swap them. Okay. So we'll say u is going to be ln x, and v prime must be x. Now you might say, oh man, okay, so that's going to complicate things. But it's still possible. Okay? Why is that? Because what is the integral of x? Well, it's x squared over 2. Okay, so actually, I mean, x squared over 2 is actually more complicated than x. When I say more complicated, you know, the power is higher. You know, it's we want to make it as simple as possible. But what is the derivative of ln x? Okay? It's 1 over x. And what you're interested really is not the u prime and not the v, it's the multiplication, the product of it. And you can see that the product will be a nice, easy polynomial. Okay, so let's write the answer. Okay, so this integral is equal to uv, okay, u times v. Okay, I'll write down v first, it's easier to see. So x squared over 2 times ln x, which is a complicated formula function, but we don't need to do anything with this, really. We don't need to integrate. If I have to integrate this, it will be difficult. Minus the integral of u prime v. And you can see how that 1x gets cancelled nicely. So it's simply x over 2 dx, which is an easy integral to calculate, okay? So x squared over 2 ln x, not nice term, minus x squared over 4 plus c, right? But differentiate that, the 2 comes out, 2 divided by 4 is minus half, all good. Okay, cool, eh? Let's move on to the last one. Okay, the last one, oops. Okay, the last one is the trickiest one. And then sometimes we do this little trick. I've got only one function, ln x. Okay? But I need 2, right? U times v. Or u times, I need the u and the v prime. So I'm just going to show it. Okay, it's just a really nice trick. I can always multiply. If I have one function, I can always multiply it by 1. So 1 will be one of either the u or the u prime. You see what I'm doing here? Okay? Now, the question is which one is which? Okay? If let's see, okay. Let's try both, okay? Let's try both. Let's say in the beginning I said, okay, it's going to be the wrong one. But I'll say, let's say u equal 1. That's never going to work. It's never going to work, okay? Okay, so in this case, u prime, what is the derivative of 1? Well, it's 0. And I know when that happens, I know it's just not going to work, okay? Because that's like too easy, really, because then the integral of u prime v is going to be 0. So, you know, it would be nice if it would have worked, but it's not, okay? You understand what I'm saying here? So here I have, let's say, v and v prime, okay? If I had to integrate and I find what v is, then it's simply going to be uv times the integral of u prime v. Now u prime is 0, so that will be 0. So it will be like, oh, calculating this integral is simply going to be uv. That's like too easy to be too good to be true. And it won't, because if you try and say ln x and you want the integral of ln x, it's just like before, we're stuck. So it's not going to work. So I want you to start seeing it in your mind. What am I starting to see here? I'll try and, before I write it, start seeing it. Let's let 1 be the v prime. Then if I go find the integral, okay, so let's make v prime equal 1. That means v is going to be x. X is more complicated than 1, correct. But what is ln x? So this needs to be in your mind. You need to remember the derivative of ln x, because we're looking for u. The derivative of ln x is 1 over x. So remember what we're looking for, what the hardest bit, I mean this uv is going to be easy. It's just substituting u times v, whatever it is. I don't integrate. That's going to be the difficult term, okay? We substitute an integral with another integral. So if this integral is too hard, if I choose the right u and v, this integral will be a bit easier. This could be complicated, but there's no integral, so you just write it down. So in your mind, you need to think about, the key thing is u prime v. U prime v needs to be easy, okay? U prime could be a bit difficult, but it's going to be cancelled by v in this case. So you need to start seeing this, all right? This goes up to x, but that's fine because it's 1 over x. So we'll write again, ln x dx. Okay, and actually now I answered myself, okay? We forgot. So before here, we were asking ourselves, how do we find ln x, the integral of ln x? And we didn't have an obvious answer. But now, using integration by parts, we do. What is the integral of ln x? Well, it's going to be u times v, x ln x, minus the integral of u prime v, 1 over x times x dx. What is that? It's 1. Okay, so x ln x minus 1 dx, or we can just call it dx. Okay, what is that? That's x ln x. What's the integral of 1? Minus x plus c. Okay, so you see now, using integration of parts, we found the integral of ln x. Okay, and as I said before, it's not straightforward. It's not too difficult, but it's not something that needs to come up the top of our head. We use integral by parts. And I just want to stress here before I finish the video, out of all these integration methods that we use, that is the one that's going to stay with you. If you carry on, if you do physics or anything that will have a lot of maths in it, obviously if you carry on with maths, that is like the one that you will end up using more and more and more and more. The substitution, all stuff difficult, but eventually you'll forget it. That's the one that will come up and there's more difficult version of it. Hope you enjoyed. I'll see you next week.